Next on Energy Switch, we'll look at batteries, where they are today and where they're heading.
At the end of the life of a battery, to drive a car, say, there's still, 80% of that energy available. And increasingly, people are understanding you can then perhaps use that spent battery to power homes, right? To, power a forklift.
I have to counter-argue here. To make that happen, we have to ensure the absolute safety of batteries. If we can guarantee the second life without any safety problems, I think it's a very valid business model.
Coming up on Energy Switch, Part 1 of Batteries for Cars and Grids.
Funding for Energy Switch was provided in part by the University of Texas at Austin, leading research in energy and the environment for a better tomorrow. What starts here changes the world. And by EarthX, an international nonprofit working towards a more sustainable future. See more at earthx.org.
I'm Scott Tinker, and I'm an energy scientist. I work in the field, lead research, speak around the world, write articles, and make films about energy. This show brings together leading experts on vital topics in energy and climate. They may have different perspectives, but my goal is to learn and illuminate and bring diverging views together towards solutions. Welcome to the Energy Switch. Batteries are everywhere today, making energy portable and our lives much better for it. 19th century lead-acid and alkaline battery technologies are still in wide use today. 20th century lithium-ion batteries have made electric vehicles a reality today, with many benefits but several challenges, including recycling and repurposing batteries, flammability and safety, and battery materials supply. In Part 1 of this episode, we'll talk about all this with Dr. Lynden Archer, battery scientist and researcher and director of the Energy Systems Institute and professor of chemical and biomolecular engineering at Cornell University. Dr. Shirley Meng is also a battery scientist and researcher, a professor of molecular engineering at the University of Chicago, and a chief scientist at the Argonne National Laboratory. Two very high-level experts on this episode of Energy Switch, Batteries for Cars and Grids, Part 1.
Let's just start with a real brief overview of current battery technology. What do we got? What's in the world today?
Well, I think everyone has at least 2 or 3 batteries in their pocket. Lithium-ion battery is the main batteries that we're using for mobile devices. But lead acid is still around, and we still buy alkaline batteries, and both of them are actually 19th century inventions. So batteries are everywhere around us.
The interesting thing from my point of view is that the old and the new coexist. And have each found, use cases that are relevant, right? So the lead-acid battery, in the early days of rechargeable battery technology, was considered to be past tense, but yet it's still here.
Right.
And still performing new functions, and I think that's exciting too.
Yeah. It's kind of common in energy. Things don't really go away that often. What's good about the lithium-ion battery? What makes that better than technologies that came before?
Lithium-ion batteries is the first electrochemical device that operate at voltage above 3.5 volt, because our transistors in the semiconductor world, they operate at 3.5 or higher voltage. So it really revolutionized how batteries in one single cell, you are able to switch on your phone. Otherwise, if you use the lead acid or alkaline batteries, you need to put a few together.
Oh, I see.
To operate.
Very interesting.
So one other element is just the reversibility of the lithium-ion battery, in part because the customer doesn't just want to have a device that, charges once, but one that charges repeatably.
Right.
And over time, you don't want to see the use life of the equipment deteriorate.
Right.
So it's an elegant, beautiful technology because it has this sort of, intrinsic feature of using the smallest, lightest element to do what you'd expect the smallest, lightest thing to do, which is to intercalate reversibly over hundreds of cycles typically.
That's interesting. What are the downsides to lithium-ion? What are some of the challenges with them?
Lithium-ion is a compromise technology. In hosting the lithium in the anode, we reduce the energy density of the battery because the safety of the device demands that we host lithium in a material like graphite. So I would argue the fundamental challenge is really how do we move to battery chemistries that don't require as much hosting, as much packaging, so we can get the sort of full bang for the buck, if I can put it that way.
In terms of weight, you mean?
In terms of capacity per unit volume.
Okay. You agree with that?
My perspective is a little bit different. The biggest challenge I see the field facing is battery itself is not renewable. So the way how we make, use, recycle the batteries determine its ultimate carbon footprint and sustainability. So I think our whole field has not been carefully thinking about this aspect in the last 30 years.
Interesting.
It takes about a 50 to 60 kilowatt hour electricity to produce 1 kilowatt hour batteries. And that's a very big numbers.
50 to 1 ratio, right?
And I think the scientists really have to work hard to think about how we can improve that. And then moving forward is really about where we put the gigawatt factory site, what electricity and the resources we use to make them, and where we use the batteries, and how we eventually going to give it a circular life. I think that to me is really, really important for the future of our field.
Can I defend a battery?
Yes.
One of the really remarkable things about lead acid batteries is that pretty much 90+% of lead in any battery today was in a battery in the past. And so that sector has figured out, how to do closed cycle battery production. So if you now look at the wasted energy that you get from other sources, including fossil fuels, where it could be order 70% of the energy that's locked into the bonds of those molecules is wasted in driving a car, you begin to realize that if you're patient and give the battery enough time, it more than pays back for the amount of energy that you put into it.
Yeah, that's interesting. You said not renewable because you have to mine for the things, you manufacture them somewhere. They do eventually wear out.
At the moment, only 20% of the lithium-ion batteries are recycled. So I do agree about the lead acid story. However, we have to do better with the recycling.
Is there just a psychology, or why don't we recycle lithium-ion batteries? I mean, I know why we don't recycle most things. It costs a bunch of money.
So one part of it is that, I think the dangers of lead is sort of somehow imprinted in all of our minds, right? And so we probably...
Mercury, lead, no.
Yeah, we probably need a similar revolution in thinking. But the other bit that I would argue is it's a volume argument, that, it's only in the last, I would say, 5 years or so that we've seen the growth in interest, actually, in recycling lithium batteries. And I think in part because there's a market now. So lithium last year was like 20,000 per metric ton. This year it's about 60,000 per metric ton.
Yep.
And you wring your hands over that. But at the same time, that might be the driving force to start recycling more things, right?
Yeah.
So bottom line, please do not dump your lithium-ion batteries in the dustbin. It has value, and we actually call them urban mining, and it is really, really critical for us to, do recycling.
What about heat? I mean, every time I get in an airplane, which is too often, if I check a bag, you don't have any batteries and blah, blah, blah. And now and then you'll hear about a laptop going, is it just a bad battery or what happens?
I think ultimately, it is the flammable electrolyte that is used in the current lithium-ion battery. So it's the reason why it can operate at above 3 volts is because we don't use water-based electrolyte. It's based on organic molecules, and those molecules are flammable. Even though there's only very little amount in your batteries. In the world, everywhere, the scientists are working on replacing these flammable batteries either with non-flammable liquid or completely solid, non-flammable.
The component that I would add to the mix is the cathode in the battery, right, which is in fact responsible for our ability to get to these high voltages. But I think often it gets there by, using things that are metal oxides, right, that has kind of intrinsic ability to drive a flame. And so, one of the real quiet revolutions I think that has happened, in the last 2 years or so, is the community revisiting things like lithium iron phosphate. These are batteries that don't give us that high potential, but they're inherently safer because they don't have this ability to feed a runaway reaction. And so I expect, as the systems get bigger and manufacturers begin to think sort of more defensively about how we design the system for safety, we're going to see chemistries that are invented that facilitate safer operation.
Interesting. Yeah. Mining. What are the challenges there? As we think about global supply of critical metals, rare earth elements, critical minerals, what are some of the mining challenges you see?
If you think of lithium, it's been projected that there are roughly about 17 million metric tons of reserve in the world, period, right? In comparison to something like zinc, where it's 250 million metric tons available. And so as you begin to now, think about lithium-ion technology at scale, the challenges of both sort of the mining you're describing, but also the urban mining that Shirley talked about. How do we do that more efficiently so we end up, sort of maximizing this resource? And I just want to put a finger on one element, cobalt, because it's mined in countries that use child labor and sort of unethical practices that are, I think, somewhat inconsistent with our values, as a society and as a culture. But cobalt is actually a good element in terms of, producing battery electrodes that are safer. And so it's not just the mining and making it greener. I think making it more ethical is an important piece of it.
Absolutely. Yeah, absolutely.
For me, green is not becoming my favorite color anymore because it does not define the technical goals. So for us, mining with carbon neutrality, to actually keep track of how the elements are mined and produced and then being used, we call it the battery passport. So just like many of the high-end jewelries, where the diamonds are always being tracked, where they get sourced, gets refined, gets sold, I believe the trend for our field is going to be that we are going to develop this type of battery passport.
Yeah, I like that.
The other thing that I would argue that will be important in the future is just the awareness of the value of this product, right? And not just the value in the sense of the materials, but in terms of at the end of the life, right? So the typical end of life of a battery is defined as when the battery energy, the energy delivers to drive a car, say, is 80% of what its starting value was. And increasingly, people are understanding you can then perhaps use that battery, that spent battery, to power homes, right? To power a forklift, or something that isn't as demanding as an electric vehicle.
I have to counter-argue here. To make that happen, we have to ensure the absolute safety of batteries. If we can guarantee the second life without any safety problems, I think it's a very valid business model.
So that's one element that, again, I'm more of an optimist that to the extent there's a technology that will allow us to have a better understanding of when a cell is close to the end of life.
Affordably?
Affordably.
Really?
Well, it's getting more affordable.
Yeah,
Let's put it that way, getting more affordable.
Interesting.
Storage on the grid is a little bit different than storage in transportation, right? It could be managed in infrastructure that is somewhat more resilient. There's a sort of built-in opportunity in second life usage for grid storage that comes just from the nature of the beast. It's intrinsically more securable, if I can put it quite that way.
Right.
Yeah.
So let's talk about transportation. Battery technology has really made fully electric cars and hybrid electrics possible. How's that happen?
I think, back in the early 2000s, a lot of people have skepticism about if a full electric vehicle is ready. I think at that time, nickel metal hydride batteries, Toyota definitely demonstrated the hybrid model works and works perfectly. I had a Prius for over 12 years before switching to the full electric.
I would argue the Prius doesn't get its due credit. But I remember my first experience with the modern electric cars was actually a halftime show where Elon Musk had the first Tesla, right? And I think that was a brilliant marketing strategy where he didn't cut corners, right, in terms of cost because he focused on performance, understanding that, once the performance meets the needs, they will come.
Right.
And I think interestingly, though, that because of the sort of commanding market presence that version of the EV has had, it has given Tesla and now others incredible power, throughout the supply chain, right? To control cost and so forth. So it's a two-sided story, right? Where the hybrid came first, but I think ultimately technology meets marketing, business savvy is why we're here.
Now the motor is extremely efficient, but arguably, and I'm not picking on batteries, but compared to gasoline, a battery per unit weight or volume is much less efficient than gasoline. So is there a trade-off here?
You use the word efficient, but I think the word you meant to use is energy dense, right? Yeah.
Dense.
So gasoline is much more energy dense. But if you actually do the numbers, right? So roughly only about 15% of that stored up energy is used. The rest is wasted in friction, in carbon emissions, and so on. And so it's an interesting argument, but just theoretical.
Of course, we can always argue how the batteries is made, where the electron comes to charge the cars. So I think the argument about it being green or not to drive the EV is a flawed one. It's more important, it's about the technology advancement. We're moving towards more efficient technology.
Interesting.
And I think the point Shirley makes is exactly the right point. That the efficiency of an electric motor is incredible. It's why batteries are the future of all types, right? Because you can get 90+% efficiency, and there's no other technology that you can do that with, where you can directly transfer energy in to work.
But you're never going to get the energy density out of a battery.
No, but we don't have to, at least just yet. The thing that's humbling is that even with what we've got now, we can do so much.
Yeah.
Right? Yeah. It tells you that, the engineering doesn't just stop with the battery. It's the whole system, the car, how you charge, when you charge, how do you optimize the lifetime of the battery. I mean, these are things that are still, I would say, white spaces, that we can write in to, make the EV even more efficient.
What are any other challenges with batteries and EVs that we haven't talked about?
The materials cost in a battery nowadays is roughly about 40% of the overall cost of the cell. And they are hard limits to where you can go, right? And it's interesting that as the market penetration grows, the cost of materials actually starts going back up. And so it's not clear there's this sort of economies of scale that you count on in other sectors. And so that to me is a huge issue. The other issue that I would argue is the kind of range anxiety of the customer. And EVs, I think, are this sort of exhibit A, where, you go to the gas station, you fill up in, 5-6 minutes, and you're on your way. There are fundamental technical challenges that makes it so that you cannot do that with any of the battery technologies we have today. And I think that, that will be an important barrier to mass adaptation.
Especially in countries like United States. I heard that probably in Asia and Europe, the fast charging requirement was not so demanding. But in US and in some of the countries in Europe, the Autobahn, they want fast charging infrastructures. I enjoy the benefits of having the car brand I purchased do have a good supercharger station. But when my friend chose a different brand, he could not charge in where I normally charge. And that is, to me, a mind-boggling problem because the infrastructure really should be shared, in my opinion.
And I think the answer to the dilemma Shirley's friend has would be for some neutral body to build a charging station so they had, like multiple outlets that the different cars can use. But the problem, of course, is that each of those outlets would have to be, first of all, warranted, guaranteed, insured for the model of the vehicle. And then secondly, the technology is just not there for some of these vehicles yet. And so it's a real issue. Costs,
you mentioned costs, we both mentioned costs. How and when do they come down?
This year is the first time in the 20 years the battery price is increasing. And that is due to the supply chain shortage.
Correct.
300% increase for the raw material supply for lithium alone, and not to mention nickel and some of the other chemicals. I think we are cautiously optimistic that this is temporary.
So, I'm pessimist and optimist at the same time, right? And so the optimist,
You're a realist.
the optimist in me have seen the cost drop by a factor of 10,
Yeah.
right, in the last decade, right? And I think against the odds. I am not too worried by this temporary increase in costs. I think if the temporary increase in costs for batteries and hence EVs drives people to recycle more, to understand that there's a market there that's worth developing, I think the long run looks good.
Yeah, and to make the batteries last 10 times longer is another way to reduce the cost.
Right.
Right, and then also there's some interesting consequences.
Is that possible? 10 times by when?
It is absolutely possible to prolong the lifetime. You have to use some special salt, some special electrolytes, but it's possible. I think the other alternative solution is that, batteries that does not use lithium, does not use nickel, does not use cobalt, is possible to go to the cost projection of $20 per kilowatt hour. There have been small-scale demo. I mean, all the question eventually comes whether scalability is there, whether can we integrate into the big system. I think there are, of course, a lot of risks associated with those new ideas, but I think I'm with Lynden in this one, that we are desperately looking for solutions to further lower the cost.
Let's talk about batteries, certainly. As you think of heavier and heavier vehicles, the trains and boats and things, can they get there? Will they always struggle to compete with denser fuels?
That's a fair point, and I think that but even as we speak, right, the companies are making long-haul trucks that are electric. And I think, in particular, actually, of the Chinese, that part of their, switch to lithium iron phosphate was motivated by this precise point. Not just in a single massive long-haul vehicle, but in a fleet of passenger vehicles, right, that are electrified.
Long-haul truck is one of the biggest challenges because its number is probably only like 13 or 14% of the total fleet, but it's responsible for more than a quarter of the carbon emission. And I think other sectors like aviation, and I think that sector is in fact very difficult to decarbonize.
So before we leave transportation, with graphs I've seen a lot of them, 15, 16, 17 million EVs in the world today. One I saw, 50 to 60 million in the next 3 years. And then maybe 600 million by 2040-ish, basically half the world's vehicle fleet. Really?
Well, I would...
600 million?
It's one thing for governments and politicians to commit to certain targets.
Right.
But of course, that has to meet reality. And so I don't mind, the optimistic projection if it galvanizes people to action.
Yeah.
And I think that to me is the more important messaging, signaling that 60 million, right? It's telling people like me who are on the research, and Shirley, who are at the research end, that my goodness, we can't get there with the current technology because, if you think of what that means, right? It means that about 80% or so of the battery capacity that we can possibly ever make would be in transportation, and there's nothing else or anything else.
Right.
So that by itself tells you there's going to be some need for variety. If that galvanizes people to now have a second look at sodium, have a different look at zinc, revisit lithium iron phosphate, think about other technologies where we have the reserves, where we can get there. I think that is a win for humanity.
That's interesting.
Yeah.
So battery tech, and we've just been talking about it, is focused on transportation a lot. What's the downsides of that? Should we be focused on other things for batteries?
Yeah, it's market-driven. And I think the application in transportation was sort of at the right time. And I think in the process, they've had the effect of making batteries better, right?
Yeah.
So I would say that if I look just strictly from the material supply perspective, I don't know that we can do much more with lithium-ion technology than electrify the transportation sector. There's just not enough to do it. But if lithium-ion technology has become an example of what we can do with zinc, with sodium, with magnesium, and other chemistries, then I think that is a really good use case.
Let's take a break. We'll come back and talk about the grid a little bit.
Lithium-ion batteries have made electric vehicles possible. There have been some challenges, like high cost and low recycling volume, but market acceptance in developed nations has been remarkable. With the appropriate safety standards, used batteries for EVs could have a second life in other applications. Battery costs have been declining over the past 20 years, but materials shortages are starting to impact that. Some charging station networks are proprietary to vehicle brands, though there's a move to democratize them. New technologies may further improve lithium batteries, but they're too large and heavy to likely power larger vehicles, like trucks, ships, or planes. And for the electric grid, we'll probably need alternative battery chemistries. We'll talk about all that in part 2.
Funding for Energy Switch was provided in part by the University of Texas at Austin, leading research in energy and the environment for a better tomorrow. What starts here changes the world. And by EarthX, an international nonprofit working towards a more sustainable future. See more at earthx.org.